audio lecture. So the last thing we have to look at is just the levers of the body, and I just want to say that a lot of kids will kind of skip this part of the chapter, but these are going to end up on your lecture exam. So just make sure you get the basics down. Make sure you know what the differences between the three different levers are and sort of where those components are going to be. Okay, so don't skip them because again you're going to miss some questions on the lecture and on the final exam. So what are we talking about? When we're talking about levers, and you can see this is like a like an old teeter totter. So that's kind of like the basic way to kind of think of levers just in general, and that's something that everybody's kind of familiar with. And then we'll look at sort of what type of lever that's actually going to be. So when we're talking about levers, we want to think about as humans, we're going to move our bodies through this system of levers, and you also want to know that like levers cannot be changed. Okay, so they're kind of based on just our structure, so they're created by the structure of the body, so therefore we can't change them. But what we can do is we can learn to sort of utilize them sort of more efficiently. And what you're going to find to do is a lot of this stuff we'll do just kind of naturally, where we'll try to put our body in positions that make us stronger, make things a little bit easier. And then we'll talk about the different levers and sort of how we do that, and how the positioning of the weight and how the positioning of your body is going to make things easier, either a little bit easier or a little bit harder. One of the main ways that you can think of a lever, if you've played any sort of golf or you've played tennis or you played hockey or anything like that, one of the things that we kind of know is that if we make that lever longer, it's going to be able to produce more speed. And this is probably, my little guy is kind of obsessed with golf right now, but this is probably one of the best examples is that, the farther I keep this club away from me, the longer my arm is, the more time I'm going to have to generate speed as this club is kind of coming into the ball. One of the main things people do is they'll sort of bend their arms and kind of shorten that lever, right? So this lever's become a little shorter, and it makes it where it's going to be a little bit slower and it's going to be a little less powerful. So just a good example of, if you played baseball, you've played any sort of sport where, if I keep my arm a little higher, keep it a little longer, or if my stick is longer, my golf club's a little bit longer, I'm going to be able to be a little more powerful and sort of generate a little bit more speed. Okay, so let's look at just the basic important components of a lever and just some important definitions. So when we're talking about a lever, we're talking about a rigid bar, and we're going to look at a picture here in a second, that's going to turn about an axis, so there's going to be a little bit of rotation, and you'll also see the term fulcrum. So sometimes these terms are kind of interchangeable, but axis, fulcrum, they're both meaning they're talking about that kind of point of rotation. Okay, so axis, the point of rotation about which a lever is going to move, and then your lever is going to rotate about an axis as a result of a force being applied. So to create this movement, we're going to have a little bit of force to kind of get things kind of moving. So force is going to be also termed as effort in some of the diagrams. And then usually we're trying to move something, right? So that can be the weight of your body, it can be the weight of your arm, it can be something that you're holding. But that's going to be, we're creating this movement against resistance, okay? And then we'll work through each of the ones so that we know like the importance of each one and the positioning of each one. But your resistance is going to be, again, whatever you're trying to move. It can be the weight of something, the load of something. All those are going to be very similar, okay? So in your body, the bones are going to represent the bars, right? So when we're doing these diagrams, your bones are going to be the bars. Your joints are going to represent the axes or the points of rotation. And then my muscles are going to be what is going to create that force to sort of create that movement, okay? So important to sort of just take the basic diagram but sort of realize like, okay, how is this applying to my body? So my bones are the bars, my joints are the axes, and then my muscles are what's going to be able to allow me to sort of apply this force and sort of move these levers around. Okay, so all lever systems are going to have three components. Again, we'll see a picture here in a second, but they're going to be arranged in three possible ways. Okay, so we get one of three possible arrangements, and then based on this arrangement, that's how we're going to know what type of lever we're sort of dealing with. Okay, so here are the 3 points. Okay, so 3 points determine the type of lever and for which kind of motion it is best suited. So we're going to have an axis point, again, point of rotation. We're going to have a point of force application, okay, so that's going to be the F. That's usually, again, going to be the muscle insertion. And we're also going to have a point of resistance, and again, that's going to be where we're applying this resistance, and that's going to be the center of gravity, usually going to be the location of whatever we're trying to sort of move, okay? But these will make sense as we sort of move through the pictures here a little bit too. So what's in the middle? The reason I have this slide is that this is kind of how I always used to remember it, and when you're trying to determine if it's like, we have first class, second class, third class levers, the way you're going to know what type it is based on which of these three things, okay, is in the middle of the diagram, okay? And we'll see that in a second here in the examples, but that's how you're going to, that's the most important thing to remember is if the axis is in the middle of the 3 points, it's going to be one type of lever. If the force is in the middle, it's a different type. If the resistance is in the middle, it's going to be a different type. Okay, so what's in the middle is going to be your key to sort of figuring out, especially on any sort of multiple choice questions or things like that, what type of lever you're sort of dealing with. So here are our three classes, okay? And this is where that middle part comes into play. So a first class lever, okay? Effort is applied at one end of the lever and the load is applied at the other end of the lever. And again, we'll see the picture here in a second. But here's the important part is that that fulcrum or that axis or that point of rotation is going to be somewhere in the middle of these two things, okay? So I'm going to have my effort at one end, I'm going to have my load at the other, and that point of rotation or that axis is going to be in the middle. Okay, so that makes it a first class lever. Second class lever, your effort is applied at one end of the lever, okay, and the fulcrum or the axis is located at the other, and then the load is going to be in the middle. Okay, so effort, axis on one end, load is going to be in the middle. That's going to make it a second class lever. Okay, and then third class lever, the effort is going to be applied between the load and the fulcrum. So in the third class lever, the effort is going to be the thing that's going to be sort of in the middle. Okay, and again, we're going to look at some pictures that'll make it a little bit easier to remember. And you want to sort of just be able to sketch these out on a piece of paper really quickly. Just sort of draw that, teeter-totter and sort of put the different points in the middle. And then, that'll help you to remember and help you to make sure that you sort of know exactly which one is which and what the important parts are. So here are our pictures, okay? So the top one is a first class lever, okay? And it's a first class lever because I have my force, I have my resistance, and then I have my axis in the middle. So if the axis is in between those two, it's a first class lever, okay? Second class lever, I have my resistance is going to be in the middle, okay? So I have my point of rotation, I have my force, and then my resistance is in the middle of those two, so that's going to make it a second class lever. And then my third class lever, I have my axis again, I have my resistance way on the other side, and then I have my force is in the middle, right? So this is where I'm trying to pull on things, or I'm trying to apply this force to sort of move these levers around. Another way to sort of remember these is that you can use the letters. So a first class letter is going to be FAR, right? So force, axis, resistance. Second class letter is going to be ARF, so axis, resistance, force, and then AFR is going to be, again, that third class lever. So sometimes you can, if you just have the letters and you know what sort of proper order they're in and you can kind of memorize those, it'll help you, again, write it down quickly so that you can kind of remember which one's which too, okay? But very, very important that you can just draw these out really easily. They don't have to be super pretty, but just sort of draw these out and make sure you know, okay, what's in the middle? Is it my axis? Is it my resistance? Is it my force? And again, that'll make sure that you know it super, super well, and that'll help you sort of answer, any of the questions that kind of might pop up. So let's look at these sort of examples of these sort of in the body, okay? So here is a first class lever. And in real life, the best example of a first class lever, okay, is going to be, sort of this little teeter-totter here, okay? Or you can look at like a pair of scissors. So if you take the pair of scissors and you think the rotation point is in the middle, okay? The load is what we're trying to cut, and then the effort is where my fingers are, and I'm sort of using my muscles to sort of open and close these sort of ends, okay? But when you draw this diagram or you think about scissors, you want to think about, okay, my effort's on one side, whatever I'm trying to cut is on the other side, and then that rotation point is going to be in the middle. And if I remember those things and I know, okay, this is where the rotation point is or this is where the resistance is, no matter what example they give you, we can figure out what sort of type of lever it's going to kind of be, okay? And then this is our example of just our normal little teeter-totter here at the top where you have one person that's kind of pushing, one person that's kind of up in the air and just sort of, resisting. Okay, and here's another example of just in the body. Okay, and then these questions are always like, I used to give these as questions, kind of like written questions, but this is kind of like a really important thing where you would say, hey, give me an example in the body, and then people would sort of put the teeter-totter, they would put the scissors. So just another example of just make sure you're reading the question and sort of giving your teacher or your instructor sort of exactly what they're kind of asking you for. Okay, but this is a first class lever in the body, and we're using our neck muscles here. Okay, so we're trying to extend our head or sort of maybe look up at the ceiling, but the rotation point is going to be your spine, okay, in the middle. My load is just the weight of my skull, and then my effort is where my muscle is going to be attached at the base of my skull. And in this diagram, right, my effort is on one side, my load is on the other side, and the most important thing is that that fulcrum is kind of in the middle of these two, and that's going to make it a first class lever, okay? So let's move on to our second class lever. So second class lever, the best example in real life is going to be the wheelbarrow. And I had a job when I was in college and when I was in high school where I worked for like a paving company, and you basically would just push a wheelbarrow kind of all day. And I mean, it was it was one of those jobs where you earned all your money, but you learned very, very quickly is that when the load or whatever's in your wheelbarrow is closer to the wheel, it's going to be way easier for you, okay? And if it gets back by your hands, okay, or wherever you're sort of holding things, it's going to be much, much harder. So you learn really, really quickly when you're working to sort of make sure you put that load by the wheel because it makes your job a lot easier, okay? And this is the classic example of, this position, the load is in the middle, so it makes it a second class lever. But even the position of this load is going to make it a little bit easier, a little bit simpler, and we'll talk about that in more towards the end of this little chapter. Okay, but fulcrum on one side, effort on the other side, the load is in the middle, and again, that's going to make it a second class lever. Okay, so the first one, you can think of the teeter totter. The second one, you can think of the wheelbarrow and think about where you're holding, what's rotating, where the load is. And then when we move to our example of the second class lever in the body, this is kind of like a toe raise, right? Now, this one kind of tricks people because we think the rotation is the ankle, okay? But the pivot point for doing a toe raise is actually the ball of your foot, okay? So I have my fulcrum, or my point of rotation is the ball of my foot. My load, okay, is the weight of my body. And then that effort, again, it's all based on where this muscle is sort of applying and sort of inserting and sort of pushing. So it's not necessarily the location of the muscle. It's actually just where that tendon inserts and what's it kind of pulling on, okay? So this is my calf muscle. It's going to come down and it's going to insert on the back of my calcaneus. So this is where that insertion point is. That's where the load or the force that's produced by the muscle is going to be sort of focused on, okay? So my effort is on one side, my weight is in the middle, and then my fulcrum is that ball of my foot. And because that load is in the middle, this is going to be a second class lever. Okay, and always good to sort of just have an example of, okay, what's an example of a first class lever in the body, what's an example of a second class lever, and then obviously what's an example of the third class lever. So here is my third class lever. Okay, so on this one, my load is on one side, my fulcrum is on the other side, and then my effort is going to be in the middle. The example sort of in everyday life is these tweezers here. So I have, I'm going to push with my fingers in the middle of the tweezers. The rotation point is on the one end, and then whatever I'm trying to squeeze or kind of hold is going to be on the other end. Okay, so my effort is in the middle, and again, that makes it a third class lever. Okay, and in the body, this is again another important thing for your multiple choice questions is that you want to realize that the most common type of lever in the body is going to be this third class lever. Okay, so these are the ones that are most of our joints, most of our muscles. This is the way they're sort of arranged. And what your body's done is this isn't necessarily like the strongest, or it doesn't allow us to be the most powerful, but it allows us to sort of have the greatest range of motion. So your body's kind of chosen, do I want to be really, really strong, or do I want to have a greater range of motion? And we're designed to sort of get this greater range of motion, which again makes us maybe just a little bit weaker, okay? But it actually, it makes our joints a little bit more functional. So in this example, this is a bicep curl, right? So I have my fulcrum here. Now this is one where you have to remember that it's not where the muscle is, because if it was where the muscle is located, this would be on the outside, but it's actually where that muscle inserts and where that force is sort of being applied. So my fulcrum is my elbow. This is my bicep muscle, but it comes down and inserts on this side, okay, of the fulcrum. So it puts the effort in the middle, and then whatever I'm trying to lift is going to be in my hand, and that's going to be my load. So the important thing with this picture is to remember, again, it's where that force is applied. In this example, the effort is in the middle, and that makes it a third class lever, okay? And remember that the third class lever are the most common ones in the body. Now, if I wanted to make myself a little stronger, okay, and we're going to talk about like resistance arms and force arms in a second, I would have to insert this muscle closer to the weight, okay? So if my bicep was inserted way down this way, it would make me a lot stronger. It would make me able to sort of move this weight a little bit easier, but it would again decrease that range of motion sort of in your elbow. So again, just an example of where your body's kind of chosen, I want to have a greater range of motion, and therefore I'm going to be a little bit limited on how strong and how much force I can apply through these kind of levers. Okay, so here is what I was talking about with this resistance arm and this force arm. And again, these are good multiple choice questions, okay? So what they're talking about with force arm and what they're talking about with resistance arm is basically just the distance, okay, between the rotation point and where the force is applied, or the rotation point and where the resistance is applied. So you can see in this example of the teeter-totter, my force arm, so the distance between here and here, okay, is about the same as the distance between my resistance arm. So I've made those kind of equal. And what you do when you're trying to move things and when you're trying to move things around, what you want to do is have the longest force arm that you can possibly have, and you want to have the shortest resistance arm. Okay, so the way we're stronger and the way we make things easier is we kind of reposition these. So in this one, in this example, the axis point is in the middle, but really the axis point can be anywhere in between, and it will still be a first class lever. Okay, so if I wanted to make this easier for myself, what I'm going to do is I'm going to move this access point closer to the resistance. So if the A is over here, the resistance arm gets really short and my force arm gets really long, and that makes it really, 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 really easy for me to sort of move around. Okay, and it's the same with my second class lever and the same with my third class lever. If I want to make it easier, so this is my wheelbarrow again, and again, if I want to make this easier, I'm going to make the distance of the force arm really long. So I'm going to move the resistance closer to the axis. Okay, and I'm going to make this resistance arm really short. And in this one, my force arm doesn't really change, right? It's kind of at the same distance, but because I've made this resistance arm shorter, I'm going to be able to apply more force and I'm going to be able to sort of lift more weight and move more things in that wheelbarrow. Okay, now the third class lever, again, is the most common in the body. And you can see with this one that no matter what I do, all I can do is make the resistance arm and the force arm about the same length, right? So it's never going to be where I have this, what they call like a mechanical advantage, where my force arm can be way longer. But what I do is I want to sort of move where this force is applied, and I want to apply that force closer to the resistance, make this force arm as long as I possibly can. And again, this is going to make it where it's a little bit easier. And again, you'll do a lot of these things kind of instinctively, where you move, you'll position things, you'll move things. Everyone knows when I'm holding something, the closer it is to my body, the easier it is for me to hold. And the farther something gets away from me, the harder it is, right? Like I can take a 20-pound weight and I can hold it close to my body and it's pretty easy. But if I take that weight and I move it, I hold it out of my hand far from my body, it gets heavy really, really quickly. And that's just another good example of this force arm versus my resistance arm, and sort of just positioning things so that you're going to be as strong as possible. So for these examples, just remember that, I want to make my force arm, okay, as long as I possibly can, because again, that's going to make it easier. And I want to make that resistance arm as short as I possibly can, because again, that's going to make it a little bit easier for me. Okay, so very important just to kind of make sure you can draw these out, make sure you know what the difference between that first, the second, and the third lever is going to be based on what's positioned in the middle. And then, how do I make these stronger? How do I make the resistance easier? How is the resistance going to be a little bit harder? And again, that's all based on the length of the force arm versus the length of that resistance arm. All right, so that's the end of chapter 10. Okay, chapter 9, we're going to move into like the physiology and the steps of a muscle contraction. But I want you to make sure you kind of get all that anatomy down. Make sure you're practicing your labeling, because again, that practical is going to sneak up on us pretty quickly. And then we'll take next week and then the week after, and we'll get the physiology down, and then we'll be ready for our lecture exams.